Hello, everyone. Today, I want us to talk about the history of numbers. So, the concept here is to look at the numbers and how the numbers started, because the mathematics itself originate from counting. So, one of the things that we look at is our understanding of the numbers and how we can use numbers to make ourselves understand how learners understand the numbers and how the numbers has grown up to. So the first question we can ask ourselves is, why do we study the history of numbers? And why is it that learners are supposed to learn and understand the history of numbers? So it helps them develop a deeper understanding of the mathematics they have already studied by seeing how it was developed over time and in various places, and what different nations have contributed into the learning of mathematics. So the main aim also why we are doing it within our setup as future teachers is that future teachers needs to have an idea of how our number system came about and develop an appreciation for numbers, so that when you see what we are using now, you must understand that a lot have gone through or has gone into what we have now, and we need to appreciate it, that it didn't just come about. So you remember that with mathematics, the origin of mathematics is counting. Because what normally happens is, especially in our olden days, when you look at our forefathers, when they needed to know how many cows or how many cattle they have, um, because they needed a count and there were no numbers during that time. So what they would do, maybe they will start by maybe putting, if I've got 10 stones, then they would have 10 cows. And that's part of the one-to-one principles. Others will do the tally numbers, right? Which is what some of the things that have been seen in some of the works by the archaeologists. And all this is part of what numbers are all about. And it's all about mathematics that has to do with um, how many things there are. Okay. So now let's look at the different things now, the different number system that were utilized. So the first one, I'm going to start with the Roman number system. So the Roman number system originate, as the name might suggest, in ancient Rome. So around the 900 and 800 BC. Okay, I won't ask you when was it originated. Okay, but I'm just giving you this information. So the numerals developed out of the need for a common method of counting, essential to communication and trade. The Roman numerals, um, a numeral system that originated in ancient Rome. So one of the things that we're looking at, they had the seven number system, right? They had seven numbers basically. So in these numbers, they have 1, 5, 10, 50, C, D, and M. And any other numbers that they have originated from these. Okay? So which means there are no other letters that can make other numbers except these ones that are here. So with these numbers, one of the things that you will see, there was a limitation with it, that the highest number they had was the 3,999. So that was one of the disadvantage of the Roman number system, that they couldn't go above 3,999. And this was based on the fact that there are some rules that needed to be followed. Okay, so now let's look at the rules of counting here. So you can see that the first one, you have 1, 2, and 3, right? And this is the major ones that you normally have here, that in everything that you do, you can only have three. Okay. So I have the I. The I can be 1, 2, and 3, and that's it. Right? You can't have four eyes to represent the four. So when you go to the next one, you always say 5 minus 1, and then 5 plus 1. Okay. And then 5 plus 2, 5 plus 3. And then when you get there, and then you move again, you go to the next one, which is the 10. Then you're gonna have 10 minus 1 to get your 9, and then the next one you add. So in this particular context, you will understand what we're talking about here, that we're talking about the concept of understanding the different tools. So you have the additive notation and the subtractive notation. So with the additive notation is the one where you have the numbers after the ones that are prescribed. For example, after the 5, you have, after the 5, for example, you can have a 6, 7, 8, because you can only add 3. But the subtractive, you can only subtract a 1 or the one before, and that's it. Okay. And if you look at what I have there, for example, I've got the 60. With the 60 there, you can see that it's going to be what? 50 plus 10. The 70 is 50 plus 10 plus 10. And 110 there is going to be what? 100 plus 10. And that's what you normally see in terms of what you see. And also, when we move to the subtractive one, you can see if I've got the 40, the 90, and the 900 there. So the 40, you can see there it's going to be 50 minus 10, right? And the 900 will be 1,000 minus 100. And the 90 is going to be the same as 100 minus 10. And basically, you can see which ones normally works and which one doesn't work. Okay, in terms of with the subtractive, is all the 4, the 9s, and that's it. And everything that has to do with those. So whether you have a 4, you've got the 40, you've got the 400, and then you've got the 4,000, the principle will be the same, right? But then you remember that here we don't have a 4,000. So that would be the different part. Okay. Now, let's look at this number here. Write the following number as a Roman number system. If you look at that, I've got here the 2000, right? And then after the 2000, I've got the which is the MM. Can you see? And then now you've got the 500 there. The 500 there is the D. Okay. So by means of looking at this, the 2000 is MM, which is this first part here. And then the other one now you can see that it's going to be what? You've got the 2000, then you've got the D for 500, right? And then you've got the 67. 60, you remember that it's going to be what? LX, right? Which is 50 plus 10. Okay. And then you've got the 7, which is V1II. Okay. And that gives you 2,567. Okay. So if you look at what I have there, is 3,479. So the first one is 3,000. 3,000 is going to be your 3 M's, right? Which is the. So after having the 3M, then now we have the 400. The 400, you can see that it's a 4. So this one is the subtractive notation. So we're going to have a 500 minus 100. And in this case, I'm going to have the CD. Okay. And then after the CD there, which is my 400, then I've got 79. 70, you know that it's going to be your 50 plus 10. Okay. And then that's your 70 there. Then the 9, it's going to be IX, which is my 9 there. And this gives me my answer there. Okay. And this makes it easier. Okay. Then now, if you look at this question here, what number is represented here? I've got MC, ML, XXI. So this becomes easier in a sense that you can see what I'm having there. M is 1,000, CM is a 900, okay? And then I've got the 70, and then I've got the 1, which is the I there. So all in all, if you look at this, this will give me what? A 1971 or 1,971. Okay. So basically, it's all about the interpretation. What number is represented here? You will see that here, this number here that I have here. Can you see I've got C, 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 C? Okay. The number on the wall is not correct because you are not allowed to repeat a letter 3 times. And that's the reason why we don't have a 4,000, because we can't have M, 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 M. So in this case, this is not correct. Okay. And then you need to understand that you are not allowed to have the 4 letters that are following each other. And that's what makes it a different thing. Okay. And not only that, you understand that there's no number that are above 3,999. So even 4,000 is not allowed. So the next one, let's look at the Babylonian number system. So the Babylonian number system had a very advanced number system, even for today's standards. It was a base 60. Base 60 is what we normally call the 60 decimal, okay? And what we are using right now, it's not a base 60, but it's a base 10, which is called a decimal. Okay. They did not use 60 different digits, but use an additive system in which the I stood for 1, and then that kapinyana there, it drew to 10. And then they just combine these symbols to get the numbers. For example, if you look at this, I've got 1 there, then they put 2, then they put 3, then they just keep on adding them, but in a different pattern, okay, to get the numbers, and so on up until 10. So based on what we are saying here, they had 60 digits. Okay. So as you can see, the Babylonian numerals for 1 and 60 are the same. Okay. So depending on, as long as it's not on the first, so it's a 60 if it is not on the first part, on the first one. So on the first place value, it will be a 1. But anywhere else, it will be based on the number system that it has. So you will see as we go on. So out of them, you have all 60 numerals there, and all these are the what they use for the number system. All 60, and you can see that the 1 and the 60 are the same, right? However, you will understand from what we have there. If you look at this number here, this one is divided into 2. Okay, I've got this 1 here, and then I've got this 25, right? And in this case, you must look at it in terms of this is 60 to the power 1, and this one is 60 to the power 2. So to the power 1, and this one is to the power 0. You remember that anything to the power 0 is 1. 1 times 25 will be 25. But anything to the power 1 is that thing. So in this case, 60 to the power 1 is 60. Then we multiply it by 1, it represents 60. So in this case, you will see that this I always represents a 1, but its value is determined by the place value where it is. Okay, because we're going to multiply it with the place value. You'll also understand from the normal number system that we have the decimal number system. If I have 257, for example, okay, this is going to be 10 to the 0, 10 to the 1, and 10 to the 2. So this is a 2, but multiplied by 10 to the 2. 10 to the 2 is going to give us 100. 100 times 2 is 200. So that's 2 represent 200. If I've got 10 to the 1, it's 10. Multiplied by this 5, it will give me a 50. And 10 to the 0, it's 1. 1 times 7 is still a 7. So that's how it normally works. So even with the Babylonian number system, the numbers still represent what you normally see there with those 16 numbers there. But the only difference is where are they situated that will determine their value. Okay. So let's look further on different numbers. If you look at this, I've got 13, and then I've got 60. So 13 and 46, right? So I'm going to split it here. Okay, this is 46, okay? And then here I've got 13. So this is 60 to the power 0. And then this is 60 to the power 1. Okay, so 60 to the power 0, it's 1. 1 times 46 is 46. And then 13 to the power 0, sorry, 60 to the power 1, it's 60. I multiplied by 13, then the answer that I get, I add it to that 46, and then I get 826. Okay, and that's what makes this how it's done. So if you look at these numbers the way it is now, can you see what I'm having there? It's gonna be splitted there like what I'm having there. Okay, so when you look at what I'm having there, I said this is 6 to the power 0, 6 to the power 1, 6 to the power 2, 6 to the power 3. Anything to the power 0, it's 1. 1 times 6 times the 55 there, I'm gonna get 55. So this is your 55, right? And then the next one that I have there, I'm gonna have your 37. Okay, and then now I'm going to have a 30, okay? And then I'm going to have a 12. So if you look at what I have there, 6 to the power 0, I said it's 1. And then 1 times 55, I get 55, which is what I'm getting here. Okay? And then the next one, I've got 60 to the power 1. 6 to the power 1 is 60 times 37, right? And then I'm going to get 2,220. And then I've got 30, 6 to the power 2, which is 6,000, which is 3,600 multiplied by 30. I get 108,000. And so on. I've got 6 to the power 3 multiplied by 12. Then I get 2,592,000. Then I add all these numbers, then I will get my total, which is what you are seeing there. Okay. So look at this one as well. Determine the following number in a decimal form. So if you look at what I have there, I've got 51, and then I've got this 32. This is 51, and this is 32, and this is a 1. And then remember, this is 60 to the 0, and then this is 60 to the 1, and this is 60 to the 2. Okay. So basically, you can see from what I have that anything to the power 0 is 1. 1 times 51 is 51. Then this one is going to be 60 to the power 1, which is 60. 60 times 32. And then the next one, I've got 60 to the power 2, which is 3,600. I'm multiplied by 1. So the answers that I get, I add them all together, and I get 5,571. Okay. And that's what makes it simpler and easier. Okay. Now, let's move on to the next one, which is the Egyptian number system. So the Egyptian developed a number system called the hieroglyphics, okay? And this one goes up until the million, okay? And it had a base or base 10 system of hieroglyphics. You know, so you've got things like a finger, a tadpole, a little goddess, a flower, an N, an I, and a spiral. So the only difference is with this ones here, you can see that it keeps going, but it will only go up until millions, and it wouldn't have anything. It doesn't have a billion, for example, because it's only millions here, which is the biggest number that they have. Okay, and in that sense, you will understand from what we're having that the numbers are represented by a little bit different in terms of the things that we have. So they use the written numeration that was changed into hieroglyphics writing, and which enables them to note the whole numbers up until 1 million, as I said. So you can see those shapes that I said. So if you look at these numbers that I have here, 3, you can see that this is 300. I just have 3 spirals. The 40, I have the 4n, which is the 4 tenths, and then the 3 will be the I, which is the ones. Okay. And that's how this one works. It makes it easier. Okay, guys. Any questions? Please feel free to send me an email and I'll be able to answer you. Okay. Thank you so much, guys.